So, welcome everyone to our Spark AI Summit and session on encryption and masking of sensitive data for Spark Analytics, with a particular focus on uh, con California Consumer Protection Act compliance and governance. So, presenting today, we're going to have myself, Les McMonagle, Chief Security Strategist at CCPA, with over 25 years experience in information security, data privacy, and regulatory compliance. And we'll have a demo by our CEO of the company and founder, Alon Rosenthal, who has also been almost 20 years in the information security space. He had his own company, ActiveBase, that he built up from scratch, invented dynamic data masking, and sold it to Informatica, which became their DDM product, and then started CCPA about 5 years ago with the idea to build what we felt was the next generation security solution. So on the agenda then, first we'll be talking about achieving that balance between data protection and analytics value. You've got two very competing forces that are opposing each other. It's how to we'll spend a lot of time talking about how to achieve that balance and satisfy both requirements satisfactorily. And then looking a little bit about the difference between hold your own key encryption versus bring your own key or cloud provided encryption. Yeah, so first, there's a plethora of different data privacy regulations around the world. What you see on the map here is just a sampling or representative sample of some of those regulations. Clearly, we're going to talk specifically about California Consumer Protection Act, in this particular session. But the one common thread you're going to see across all of these is that these are all generally converging on a internationally accepted set of standard privacy principles. Things like, you only collect the data that you need to provide the service that you're, contracted or offering your, customers or consumers of the data subjects, that you only keep the data for as long as necessary to provide that service, that you honor that data subjects rights to have their data deleted or removed when they want, that you honor their consent or preference management, what they've opted into and what they've not opted into or opted out of, that you honor that, and you do it in a consistent way. So these kinds of privacy principles are going to apply everywhere, and if you really keep those in mind and you go into this with this privacy by design from the beginning and build privacy compliance into each new initiative, it'll be a lot more streamlined. You'll have much better compliance with a lot less effort, and you'll do it in a a more cost-effective way than you would if you try to bolt it on afterwards. So let's look at a few common use cases. First, you're going to have situations where you're going to have special controls, restrictions around, VIP or celebrity customers. When Beyonce checks into a hospital, everyone working at the hospital wants to know what she's in for. When I check into a hospital, the only person that barely cares is the doctor treating me and the X-ray tech that's going to do the X-ray. So the same thing happens with casinos with high rollers, or banks with high net worth individuals, especially if it's an investment bank operation. So every organization is typically going to have those records that require special treatment or special consideration. Another one is cross-border data flows, where different privacy regulations have restrictions on where data is stored physically, which is becoming more and more of a challenge, especially when organizations move to the cloud, because nowadays you have less and less control over where the data is physically, or it's just more abstracted from what's going on. Most organizations, they really need to focus more on the logical location of the data, who gets to see what data under what circumstances, depending on where they're accessing the data from, as opposed to where the data is physically stored. And when you move to the cloud, you might not even have any control over where the data is physically located. That might be completely within the span of control of the cloud provider themselves, unless you have special requirements in your hosting contract with them. And then the consent and preference management, as we mentioned earlier, this is a big part of providing any privacy compliance, is making sure that you're only using the data for what you've gotten permission to use it for, and you're only keeping it for as long as you should. You're not sharing it with anyone that you haven't specifically stated and got permission that you're going to share it with, etc. In the US especially, most organizations, if they've ever suffered any financial penalties for privacy violations, it's usually been a contractual violation of their own privacy policies, where they clearly stated, we will not share your data with anyone under any circumstances, and then they went and did it anyway, and you found that out. In almost all cases in the US, it tends to be somebody just didn't do what they said they were going to do. So another very important thing to keep in mind is say what you're going to do and do what you said when it comes to your privacy policy for your company. And then, the last one, real-time behavior and analytics monitoring. This becomes very important to be able to establish what is normal access or use of the data. With any organization, it's going to be hard from right up front to know exactly how a data scientist or data analyst is going to have to use that data. So being able to collect information that lets you see who's accessing what data under what circumstances, what applications they're using, what columns, and they need to see how many records are typical access and so on. That lets you establish that baseline or profile for that particular user or peer group, and lets you then be in a much better position to detect anomalous or suspicious activity for that group or a particular user. So now we come to this, the balance between these two opposing forces. On the one end, you've got, the data protection and privacy compliance rules. Personally identifiable information or private health information has to be protected, and accessed strictly controlled on a need-to-know basis. There's, quite a few laws like CCPA that now are enforcing this. Okay, you've also got to, manage all that consent and preference management that we talked about. Well, all of this kind of flies in the face of the advanced analytics and monetization of the data, where you really want to have completely unlimited access to all the data at all times using any application. For any one of your data analysts or data scientists, you want to have complete flexibility on the mobility of the data and where you host it and why. You might, if AWS is offering a deal over Azure 1 month, you might want to move it over. You've got elastic consumption of storage and compute capabilities that you spin up and spin down. And it's very important that you maintain that freedom to leverage any and all analytic tools, but at the same time still be able to apply consistent privacy compliance. So when you do this, then there's a few different specific things that you need to make sure that you do. First, that data loss prevention sort of category, being able to prevent abuse, being able to detect when a trusted insider is doing something malicious or unauthorized or abusing the privilege that you've granted them, or worse, when their credentials somehow have been compromised and you've got an external hacker or other rogue employee that's gotten a hold of someone else's credentials and they're accessing data through an account that would otherwise appear to be authorized to see that data in the clear. So being able to provide very fine-grained access control, being able to lock down and establish a profile for how one user uses the data versus another, puts you in a much better position to be able to detect then anytime you see suspicious or anomalous activity. Being able to control the cross-border data flows or the geofencing of access to the data. And then on the governance side, of course, you're going to have very specific or prescriptive rules that have to be enforced within the different regulations. Like supporting someone's right of erasure. That's a really clear, definitive functionality that has to be a requirement that would be built into any data set or data repository or application that is accessing personally identifiable information. Being able to support someone's right of erasure, etc. And then on the encryption side, most privacy regulations don't mandate or require particular data to be encrypted, but encryption, when used appropriately, is a very powerful tool to prevent unauthorized, access or unauthorized exposure to any sensitive data. And for particularly sensitive fields like social security numbers, credit card numbers, a few others, date of birth, and so on, uh, these are quite often selected then for adding an additional layer of security where you apply column level encryption or field level encryption, or tokenization to those particular fields. And in the case of outsourcing to the cloud, to be able to uh, use encryption to anonymize records before they're copied to the cloud, so that if I've changed the first name and the last name and the date of birth, email address, phone number, social security number, I've encrypted each of those before I host it at a cloud provider. I don't need to worry about that cloud provider ever being able to see any of that data in the clear, or I'm not going to suffer any damages, and neither will my customers if there's some inadvertent data breach at that cloud provider. So when you look at the two different ways that this can be done, on the left we have the normal cloud service provider encryption. This can be applied at a disk level, at a file level, they encrypt the entire database, for example, or where they apply it at a column level. So you either have situations where the cloud provider gives you a solution for doing that. It'll be unique or different for each cloud provider. So if you're using, a hybrid cloud environment or a mixture of on-prem and in the cloud, it's going to be challenging if you have separate encryption solutions on each platform. And a lot of cloud providers, then their response to this was, well, you give us the keys, you bring your own key, you give us the keys you want us to use to encrypt the data, so you control the keys. But ultimately you're not controlling the keys, because you're really just handing over the keys to somebody else for them, and you're trusting them in the same way to only use them the way they're supposed to be used. So any of these bring your own key solutions or cloud provided solutions have limited applicability when it comes to very sensitive or regulated data. And for most organizations, they simply don't fit the trust model that their internal compliance or information security group is trying to maintain. Now, on the other hand, the hold your own key concept, you have the same, where you can check the box that the data is encrypted at rest, but you can have the exact same keys used to protect the data, whether it's on-prem or in the cloud, and the keys remain on-premise. You encrypt those particularly sensitive fields enough to anonymize the records before they ever leave your organization, and they're only decrypted on the fly at runtime for authorized users on consumption. So now there is no data breach that could happen at a cloud provider or at the data layer that can expose any of that sensitive data in the clear. So it's a much better approach. It's a much better trust model for a lot of organizations, and quickly becoming sort of the standard for cloud implementations. And even organizations like Gartner and that are recognizing this and making recommendations to that effect. So when you look at this, then you start right from the data flow, from end-to-end protection of the data. One single pane of glass access control and protection solution, so that you want to have the data and that column level encryption applied right at the ingestion point. So whatever ETL tool you might be using to load the data into your cloud or on-premise data repository, you want to apply the encryption keys before the data is loaded into the data repository. Then it remains in its encrypted form anytime it's hosted in the cloud on the compute or data layers, regardless of your platform, whether it's Spark or anything else. And then to decrypt at runtime, based on various user or data attributes locations, the application someone's connecting from, their job title, what role memberships they have, that they would only decrypt whatever columns, are needed on a need to know basis uh, for that particular user at runtime. And having this where it's a centralized solution that's managed from one point is much more cost effective and more consistently applied rules than having, individual proprietary solutions that are unique to each platform. So a common customer or a common situation that we have at one of our customers, one of the Blue Cross Blue Shield organizations, they were using primarily Talend and a little bit of NiFi for loading data into the cloud. They were using Azure. They would selectively encrypt individual columns before loading them. So even though they might only be encrypting 7 or 8 columns within, customer and transaction tables and so on that are loaded into the cloud, they're still controlling access at a fine-grained level to hundreds and hundreds of columns across all different tables, independent of the ones that had that extra layer of security, that encryption at rest. So then on the Azure cloud, of course, you've got only anonymized records. And then regardless of whatever tool someone's using to access that data, whether it's, Spark or anything else, on the consumption side, you're unprotecting the data at runtime for the authorized users. And, this satisfied all of Blue Cross Blue Shield's requirements. They wanted the patient ID and several other particularly sensitive fields like social security number to be encrypted at rest. They wanted to have a complete data discovery and data flow mapping capability that would allow them to gain insight into how the data is being used by who and under what circumstances. And that helped them to fine tune their fine-grained access controls that they were putting in place. And they were insistent that it had to be a hold your own key concept. They weren't allowed to go to the cloud unless they could show that these records were going to be adequately anonymized or at least pseudonymized before being loaded to the cloud. And they needed to support a wide range of different platforms. They were obviously a heavy Spark user, but also had other platforms that they had to use at the same time. So what we're going to do now is take a few minutes to have Alon run a demo on Spark, letting you see how, even though you've got columns that are encrypted at rest within a data repository, you can still access the data, you can still perform joins on those protected fields, you can still do searches, etc. That pretty much all of your analytics can be done in a way that's transparent to the end user. We'll show you a few different examples on Spark and Kafka, and then we'll come back to continue the session.
Welcome to this demonstration on how CCPA can protect Spark and similar systems. Here is a Jupyter notebook which I will use to interact with our Spark system. This particular Spark system includes a special ingredient, namely CCPA, which is currently embedded into the Spark application. It is now watching everything going on in Spark, and it will react if and when necessary. Spark is getting customer data from our BigQuery system. This is how that data is stored in BigQuery. We also have this details table associated with the customers table, which we usually join with the customers table on the SSN column. The join looks like this. Now back to Jupyter. I will now initialize my Spark session by running the first cell. I'm connecting to Spark using a user called Jan, which in CCPA we set to be an analyst that must work with encrypted data. Now I will initialize my data frames that will read from the two tables in BigQuery. And if I run this command that will show the data is presented to me like this. The sensitive fields, namely these 4, have been encrypted in my view. But despite that, I can still run a join with the other table, because that other table also has a field SSN, which is encrypted in the exact same way as the SSN field here. So when I run this cell, I get this. Switching gears a bit, let's now consider a scenario where I upload my data into BigQuery already in encrypted form. I have done that and uploaded the data into this customer's enc table, and it looks like this. I've done the same to the customer's details enc table. Then in SecuPy, I'm changing the role of Jan so that I get to see data in decrypted form. Now back in Jupyter, I run these cells, and this is what I see. The encrypted sensitive fields are now shown to me in clear text, as if I were working with a table that was not encrypted at all. I can also run joins like this one. Again, I am able to receive data because the SSN field in both of these tables were automatically decrypted for me in a consistent manner, which allows the joins to work. In our setup, we embedded SecuPy in the Kafka producer so that when we stream the data into the Kafka cluster, we implemented a rule that will encrypt one of the fields here, namely the first name. So when the data landed in the cluster, they looked like this, with the first name fields encrypted. Now on the other side, we will query the data here using KSQL. Now in KSQL, we also embedded SecuPy in it so that it will implement the rules that we implemented or defined in SecuPy. On the left-hand side, I will log in as user Adam. And on the right, I will log in as user Tom. In our SecuPy rule, we specify that Adam is authorized, meaning he can see data in clear text, while Tom is not authorized. Now I'm going to run these queries on both sides. And as you can see, they don't see the same thing. Tom continues to see the data in encrypted form, while Adam is now able to see the data in clear text. And we can go beyond that. I can run as Adam a query like this, where I'm using a clear text value in a where condition in the query, and I get a result. Even though that in the Kafka cluster, we don't have a row where the first name is equal to this value. So even no matter how complicated the query is that Adam is executing, he can rest assured that the table that he's actually querying will be assumed to contain clear text value, even though in reality it doesn't.
So now that you've seen a few quick examples of how this can work in Spark, we'd like to go into a quick poll question for the audience. And if you could, please answer just this one question. How important is it for your organization to apply, column level encryption or hold your own key prior to data being hosted in the cloud? You may find that this is essential to your organization and it's critical, like Blue Cross Blue Shield did, for example. Maybe just a nice to have, but you don't think it's a requirement, or it's not required, perhaps because your organization doesn't host any sensitive or regulated data in the cloud, or you're not even doing anything in the cloud, and it's not a question you even have to think about. Or are the cloud hosting providers, file level encryption, and key management, features of functionality that they offer, are those, considered adequate by your information security and privacy people as, fully trusting the outsourcing of that to your cloud provider? So if you could just pick whatever one of these you think is the most appropriate for your organization, that would be most appreciated. Thanks everyone for your responses. Most appreciated. We'll certainly, make those available if they're not available before the end of the session, the results that we got back. So this is clearly something that, a pretty wide range of customers that we see in the marketplace, really care about this, being able to provide, this privacy compliance and very granular data protection is a very high priority for any organizations, processing sensitive or regulated data, regardless of what country you're operating in. And, the data protection is a very complex global issue. It's not, as simple as most organizations think it might be initially. You can always, your business may be global, but regulatory compliance is still local. And we'd like to stop now and go into, spend the rest of the time just for open Q&A. We've got several people online, Alana, myself, and a few others that will be able to respond to any questions you have in the chat window. And, we'll try and answer as many of them as we can, in the time that we have left in the session. And then just while we're providing answers to those questions, if we could have everyone also complete your feedback using the normal channels, provided by the event. And look forward to seeing you hopefully in person next year rather than just over the video conference. Thanks for taking the time, and we'll stay online to answer questions till we're out. Thank you very much.